So number 2, direct substitution. Number 8, 1/3. Number 16, negative 1/16. And number 22 is 2. Really? Nobody got confused on number 16? Everybody figured out it was negative 1/16? Yeah. Thank you, Jacob. Who else didn't get that? It was weird. Look at that. Yeah, I would have guessed 0, like without maybe checking some more. But maybe some of you guys saw that the decimals were getting established. 0.06, 0.062, 0.062, maybe 5. So that would have been really hard. I thought number 16 was really hard to figure out in the calculator. So maybe you didn't figure out it was negative 1/16. But maybe you did say, well, I think it's negative 0.5. Like, that's okay. Maybe you didn't get the fraction because you didn't solve it algebraically. Remember, that's what section 12.2 is. What do I mean? Guys, what would happen if, hold on, the end of this section, I know that it said to use a table, and that's okay, that was good. But the point of the table wasn't that you learn how to solve limits just with a calculator. That's not the point of the table. The point of the table is to get the idea of, what's the key word with limits again? Approaching. It's all about the approach, not the at. Even though we're going to use the at as a shortcut, sometimes it's about the approach. But this section did introduce us to something that we used in 12.2 a lot, and that is the very first step to algebraically solving a limit is to try to do what? Plug it in, plug it in. What happens when you plug it in? I know that that's ahead of what this section was, but that's okay, plug in. 1/4 minus 1/4 is 0 over 0. What do we do if we have 0 over 0? Keep going. So is there a way to solve this? The answer is yes. Just at this point, you wouldn't have known, and that's okay, at least not necessarily. They didn't even expect you to figure it out. Yes, they gave you the answer of negative 1/16, but what would you have seen in the table? I don't know, negative 0.0625? That's okay. That's okay. This one pretty obviously 2, this one pretty obviously 0.33333, which hopefully you thought was 1/3. But it's okay if you didn't get that fraction. Does that make sense? We all tracking? Okay. We're learning better methods of solving limits beyond the table. The table is all about cementing, hopefully, in your brain. It's all about the approach. Thank you. Okay, next page. Number 28, the limit does not exist. The limit does not exist. What's all the snazzy wording saying? F of x is approaching -1 from one side and +1 from the other side. And what do we do if the one-sided limits do not agree? The limit does not exist. If they're not headed to the same diner, if they're not headed to the same location, I can't say they're agreeing on where they're approaching. I can't say that, so the limit does not exist. Number 30. Now hold on. What does the graph of number 30 look like? You should have sketched it. What's number 30 look like? I know it's not approaching a real number. I know it's not approaching a real number, but you should sometimes still have an answer, even if it doesn't approach a real constant. Are they in agreement or in disagreement? Okay, if they're disagreeing, then yes, the limit does not exist. Good. If they're disagreeing, the limit does not exist. If they're agreeing, we would still answer with either a positive or a negative infinity. But thank you. They're not agreeing, so the limit does not exist. Number 34, you were just graphing? Oh, that's random. I don't think the graph really helps on that one, but that's okay. Did you guys get the limit was ln of 8? By plugging in. Number 38, same thing, Bob. Whoop, whoop, whoop. Graphing and looking at it, but this time you're not looking at some weird, like, this one you're looking at -1. You're not even looking over there. So, yeah, the limit exists. They approach from either side. But this one, as you approach it from either side of 2, did the limit exist? Say it with confidence. No. Why? One direction? The red car, is that the one from below? The red car is going to positive infinity. The blue car is going to negative infinity. They do not agree. Then this one, you were plugging in the properties. Boom, 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 boom. This one, you were plugging and chugging because it was a well-behaved function. Plugging and chugging, well-behaved. Plugging and chugging, well-behaved. Dun, 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 dun. Was 64 the last even? Nice. Plug and chug? It works. You plug it in, you chug it. Now, if this was an AP calculus problem, a free response AP calculus problem, think kind of like a DBQ or like a FRQ, it would not be the whole thing. It'd just be one little tiny itty bitty part. But you wouldn't have chugged it. You would have just plugged it. You would have just plugged it in and been like, ha-ha! yeah, and you get to stick it to the man and not make it wrong by simplifying, which is kind of cool. Something spiffy on the FRQ portion of the AP test. Some of my AB and BC kids are still having me get mad at them because they are trying to simplify and sometimes mistakes happen. Sadly, this one, you kind of have to simplify your trig. Ooh, the unit circle is still important, even past pre-calculus. Anyway, but in here, you would have wanted to not just plug it, but also chug it, actually simplify it, actually solve it down, and then be able to grade or check in the back of the book. Questions, odds or evens? Going once. Going twice. Sold. Back of your spiral, workspace. I want you guys to play with this. Well, you should be in your spiral anyway, right? No big deal. Ready, set? You're in your spiral. You're grading your homework. I don't get why this is so weird. Shouldn't be. Workspace. You can call it 12.1 practice. I know, it's a horrible copy. That's all right. You can still read it. I want you guys in your groups. You can talk about it. You can think about it. Justify. Ooh, justify. Something great that shows up on FRQs. Why am I saying FRQs? Because we're starting on calculus. And whenever I start on calculus, I start talking about the AP test. But don't worry. It's a long way away for you guys. It's next Tuesday for them. Okay, focus on the question. No. This isn't like a talk and just write down mindlessly. This is an actual like, hey, write and think. You're supposed to be doing it. Go. I'm going to ask you what you think in just a moment. Talk it out. Is it super straightforward? Is it a trick? Is it obvious? Justify whether you think true or false. Why do you think true? Why do you think false?
Just ignore her. I'm talking to Ryan. I'm talking to Ryan. They don't push the thing.
How many of you, not like groups as in you have to speak for your group, but for you personally, you're like, I'm 100% sure of my answer. Go. That's it? No, you guys didn't discuss enough. I know. I don't know. The rest of you guys? Okay, how many of you guys are at least 90% sure? Okay, all right. So people just were scared of the 100% sure. I get it. All right. Hold on, let me just think through. Let me read through first. The limit of a function as x approaches c does not exist when the function approaches -3 from the left of c and 3 from the right of c. Okay, how many of you guys say true? How many of you guys say false? And some of you didn't vote because you're too scared. Why? Come on. All right. Pause. Let me just write it in, let me write it in calculus speak, okay? In calculus speak. Ready? The limit of a function. Couldn't I say the limit of f of x as x approaches c. Are we good? Okay, the limit of a function as x approaches c. That's what this whole blah, 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 blah is. Does not exist. That's what they're saying. When the function approaches -3 from the left of c, do you guys agree? Isn't that below c? When the limit of the function is -3 as x approaches from the left of c, and from the right, which I'm kind of just jumping ahead from the right of c, right? The limit is what? Does this make sense? Red cars going there, blue cars going there. The question is, are they approaching the same? And the answer is, most definitely not. The limit does not exist if the one-sided limits do not agree. So those of you that said true were completely and totally and absolutely right. The question was, in your minds, did you know why? Hopefully, yes. Does it make sense now? Does it make sense now? What if I was to ask you this one? Stay in your workspace. I think there's another one. I want you to draw the graph and then try to answer A, B, C, and D. Go! Okay, focus. Yes, you may be collaborating in your groups, but focus. These how do you see it can be tricky. Sketch the graph. How many groups are still discussing? Okay. 30 more seconds.
This is what we learned, Kevin. Wait, oh, you're saying that, oh, the straight line is also approaching. I guess you can say
All right. I'm not going to ask the whole 100%, 90% sure. Well, let's do this. If this was a quiz right now, these 4 questions, each worth 25%. 25, 50, 75, 100. If you missed 1, it'd be a 75. Missed 2, it'd be a 50. Missed 3, it'd be a 25. Missed 4, it'd be a 0. How many of you guys think you would pass? 75% or above? I mean, the 50 is an F, right? Okay. All right. Let's see. Someone tell me what A is in English. Calculus speak, it'd be F parentheses 0 parentheses. But in English, what is letter A asking for? Don't tell me the answer. Tell me what it's asking for. What would the words be? Good. What's the y value or the function value when x equals 0? What's the y value or the function value when x equals 0? 1. Where's the filled in circle? What is the y value when x is 0? Not that. That. Right there. 1. Have you guys got it right? Ooh. There's no limit. It's just f of 0. It's just an at. Yes or no? Oh, you're just solving. Do you guys need to adjust your answers to B, C, and D now? Oh, no. It's not true or false. Use the graph to decide whether the value exists. If it does, then find it. So, does it exist? If so, give the answer. If it doesn't, say D and E. Does that make sense? Okay, adjust your thinking. What's letter B asking? That's the calculus speak. What's the actual wording? As x approaches 0, sure. What is y approaching? Good. As x approaches 0, what is y approaching? And technically, since there's no plus, there's no minus, it's defined to be from both sides, right? So as you come from both sides of 0, what's the limit? Why does it not exist? I heard it right back there. Why does it not exist? There are 2 different approaches. So some of you guys were answering from just below. Some of you were answering just from above. But the limit as x approaches 0 of f of x has to consider both. Are they approaching the same place? No. So the limit does not exist. Pause. Do we understand? Okay. Letter C. Same thing as letter A. What's the function value when x is 2? What do you guys think? Why does it not exist? There's nothing there, and there's no filled in circle anywhere. There's a hole, and there's no alternate point. So D and E. Why? There's a hole and no other point. There's no point at or when x equals 2. But letter D, what's the answer? It's 3. Why does the limit exist, and why is the limit 3? It's all about the approach. The door is locked, but they're there. They're there. The straight line wasn't there. Oh, at all? Yeah. Still D and E because you have to come from both sides. Still D and E because you have to come from both sides. But let's say it was something like this, and that wasn't there. Then the limit would be 4. Does that make sense? So if you had this side coming in, we're good. Yeah. Any questions on A, B, C, or D? All right, let's get the lights on. Let's get back into section 12.2. Here we go. How many of you guys passed the A, B, C, D? All right. We were here multiplying by the conjugate. Does anybody remember when we multiply by the conjugate? When there's a radical. Wait. When there's a 0 over 0, keep going, and you have a radical. So the big camp is 0 over 0, keep going. The special case, like the special condition, is and you have a radical. Because if there's a radical, you can't necessarily just factor or do polynomial division. That first trick or that first strategy to try won't work. Factoring or polynomial division won't work if there's a radical. So therefore, what do we do with a radical? Conjugate. So 0 over 0, keep going, radical conjugate. And it worked on Friday. If we had plugged this function into our graphing calculator, and if we had done a table, and if we'd done 0.000001 and negative 0.000001, we would see it going to 0.5. But we want to be able to do this by hand. We don't want to have to depend on our calculators. And in last night's homework, didn't we see that depending on our calculators can sometimes, oh, that's not you guys, lame sauce. That's not going to be helpful. On that one with negative 1/16, depending on our calculators is a bad idea because there might be some nasty decimals that we wouldn't know the fraction equivalent for. So what are you guys going to do for this one? First things first. See if it's 0 over 0. See if it's 0 over 0. So guys, if we plug in, the limit is gone because we're actually solving this puppy, right? What do we get? All right. Since we have 0 over 0, then we keep going. If it wasn't 0 over 0, it might be a nicely behaved function and we'd be done. So as you guys start multiplying by a conjugate, I'm going to write up on the board an example of when we wouldn't have kept going. You guys keep going. Multiply by a conjugate. Try to use the example we did on Friday. But I'm going to show when we wouldn't have kept going for this very function for us to consider after you try this problem. All right. What conjugate am I talking about? What are you supposed to be multiplying? Good. Take that radical expression that I don't know how to factor, I don't know how to change. Because x is x is x. There's not really much to change him. If I look at that radical and I'm like, ugh, if only I could kind of change it up or I could factor. Well, we can't factor, but what we can do is take his conjugate, which will do some pretty cool things with the difference of square properties. But what I do to the top, I must also do to the bottom. Yeah. Why must I rewrite limit? I haven't taken it. I've backtracked. I plugged in, it didn't work, so I've backtracked, and then now the limit is still there. It's not done until the x is out and I've plugged in. Difference of squares, guys. Outer and inner cancels, right? It's just the f and the l. It's not the oi in FOIL. So then the square root of x plus 4, square root of x plus 4 will just be x plus 4. The outer positive 2 root, the inner minus 2 root, that cancels. And all I have left is minus 4. Ooh, how's this going to look? Exactly. See it? And once I reduce that away, still rewriting the limit, why did I keep that little x factored out? I distributed that one and I didn't the bottom. Because what am I hoping can happen to this over 0? I'm hoping he'll reduce. That's the hope, like that one that Joseph answered on Thursday. Then we actually figured it out, like how we are going to factor and do polynomial division on Friday. We're hoping with factoring to be able to reduce the problem. We're hoping with multiplying by a conjugate to be able to reduce the problem. And can I? Yes. What's done when you reduce? What's left on top? A 1. Good. We're not canceling. We're not subtracting. We're dividing. 5 over 5, 10 over 10, x over x are all 1. Why am I not writing the limit? I'm solving. Dun, 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 dun. I've written 2 different examples up on the front board for us to consider where the outcome would have been a bit different than the one that we just did. Where the outcome would be a bit different than the one that we just did. It looks super similar though. So just a quick little beware, quick little warning when we're doing these. What if you were to be given, I'm just going to split this in half, two different problems but similar. The limit as x approaches 1 of the square root of x plus 4 minus 2. Why would we not multiply by a conjugate in this one? It's not 0 over 0. Exactly. This one I can plug in. So that's why we always have to check first, because if your brain always just says, like, ew, it looks gross, 0 over 0, you're going to get in trouble. Because this one would be rad 5 minus 2 all over 1. I mean, yes, we could simplify that to be rad 5 minus 2, or negative 2 plus rad 5. But either way, all of these answers, all of them are right. So we always need to try to plug in first, because sometimes even a nasty function that does have a problem somewhere, we're taking the limit somewhere else, so it's okay. But what about the other variation? Because the other variation, ooh, it's over 0, 0 over 0, keep going. That's what some people would do without even thinking twice. But the problem is, I changed the problem just a little bit. Why would I not multiply by a conjugate on this one either? Isn't the top the nasty rad 5 minus 2 thing over 0? This one is not dealing with a whole. If it's not dealing with a whole, can we use our trick of just factor out the whole? Or cancel out, or reduce the whole, I should say. Reduce, not cancel. My whole thing of keeping going is not going to work. It's not going to work. Because there is no shared factor. I need to 0 over 0, go looking for the shared factor or the shared term or the shared piece that hopefully, if I just do my math correctly, will eventually show up that I can reduce, like this one right here. Now, have we learned exactly how to do this one yet? Nope. So for right now, we're going to do a big question mark. Are we going to learn it? You bet your bippy we are, but not right now. You haven't heard that one? That's an old phrase. It's an old phrase. I have a mom that grew up on a farm. Kind of. Her dad couldn't really decide whether he wanted to be a farmer or a teacher, whether to live in Ohio or to be a teacher down in Orange County. It was kind of funny, actually. But different story for a different day. They moved back and forth like 5 times. Back before there were planes or moving trucks. And they took chickens in the back of their car to California. Anyway, bet your bippy, lo siento. Bet your bottom dollar. Have you heard that one before?
Yes.
Take it to the bank? Heck yeah. Anyway, here we go. We're going to learn how to do it, just not right this second. Wait a minute. What's step number 4? Step number 2, factor polynomial division. Step number 3, multiply by a conjugate. Step number 4, use a graphing calculator. Well, that's kind of lame. Well, okay, it is a strategy. If worse comes to very, 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 very worse, and you can't figure out what's going on, maybe go to your calculator, see if they seem to be agreeing or disagreeing. However, there's more math that you can do besides just those 4. So let's look at a weird example that you might be like, calculator. No. No. Don't just automatically be like, she put a calculator up on the board as a strategy, so I'm just going to use it. That's lame, because the calculator takes more time. You put in this function, you might enter it wrong, you have to go to the table, you have to approach from either side, delete out the old ones, maybe get this nasty fraction, decimal equivalent thing that you don't even know. So much better to do it by hand and just use your algebraic skills. But why wouldn't you like this one? You have to factor a cubic. But wait, what did I say you could consider if factoring isn't going well? Polynomial division or grouping. But some of you might not realize the grouping actually works on this one because it doesn't usually work from the get-go, from the beginning, from the outset, whatever you want to phrase you'll understand. Anyway, so yes, you could do grouping if any of you want to look at it quick, and it's so much nicer and easier and pretty and awesome and gorgeous. But they don't all work that way. So instead of me showing you the nice shortcut for this one, let's be able to approach any one. Why am I even saying factoring? Why am I even saying grouping? Plug in. 0 over anything is 0, right? We're done. 1 minus 1 is 0, plus 1 is 1, minus 1 is, why am I thinking factoring? Because it's not 0, it's 0 over 0, which means keep going. But the nasty thing's in the bottom. That's okay. Can't we still figure out how many times the bottom, I should say the top goes into the bottom? Now, let's see what happens. Because some of you need to be very, 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 very careful with what I'm about to show you. Doesn't the top normally go in the box? So why am I going to go the other way? Trust me and go with me on this. Trust me and go with me on this, but then pay super close attention what I do with the answer. Maybe some of you can be thinking ahead as to what I'm going to do with the answer. X goes into x cubed. How many times? X squared times. X squared times. Right? Then I have x cubed minus x squared. What happens when you subtract and they're exactly the same? Okay, 0. Well, bring down the plus x. And I like bringing down everybody so I don't forget anyone. Super easy to do sometimes. Plus 1. Oh. Well, isn't that just x minus 1? What happens when you subtract the same thing? 0. What am I going to do with that answer? I'm going to say that's how many times the top went into the bottom. I'm not saying this equals x squared plus 1 because it doesn't. It's the reciprocal of x squared plus 1. If we were to flip this and do 1 over x cubed minus x squared plus x minus 1 all over x minus 1. I could say this, and I could say, oh, there's my little polynomial division. He goes in the box, he goes outside, and then divide. That's what goes down there. So we can do polynomial division even if it seems upside down from when we would normally do it. We just have to make sure it's 1 over that answer. And why is everything all better? Because this division got rid of who? The shared factor. If you had done the grouping, did anybody figure out the other way of going? Wouldn't you have gotten the limit as x approaches 1 of x minus 1 all over x minus 1 times x squared plus x? Nope, 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 nope. And x would have come out. You would have had x minus 1, sorry, an x squared would have come out. X minus 1, x squared plus 1. Anyway, you get the same place, to the same place by doing the polynomial division. At this point, the limit's going to disappear because what am I going to do? Good. It's like taking a square root. Taking a limit, the limit's now gone, the answer is there. Dun, 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 dun. So that was a weird example. It's a little funny. Had to think a little hard. Some of you, the grouping would have been easy if it always worked. I would have just gone that route. But just because it doesn't always work, I went the nasty polynomial division route. I wonder if we'll see anything else weird or funky. Ooh! Oh, come on. We've been seeing complex fractions all year. What would I tell you to do? Pause. Time out. Plug in. Maybe it's not even a problem. Plug in. Maybe it's not even a problem. Some of you have already plugged in. You're like, well, bang goes that theory. Anyway, come back. Okay, so 0 over 0. We got to keep going. Isn't factoring a way of simplifying? Isn't polynomial division a means of simplifying? Isn't multiplying by a conjugate a means of simplifying? So what are we going to do to the complex fraction? Simplify. Simplify. Here's my way, the way that you've seen all year. I'm not introducing it, I'm just reminding you of it. My way would say, hey, look at the top, look at the bottom, find the innermost or the stuck little denominators. Not the whole denominator, the stuck little denominator. Who's the stuck guy? Right there. What am I going to do? Multiply top and bottom by. What's going to happen? 1 minus x plus 1 all over, that's okay. X times x plus 1. You can pack up. Isn't? Aren't the 1's going to reduce? Cancel? Then aren't the x's going to reduce? Aren't you going to get negative 1 over 1, which is negative 1? Hey, it's in the notes. It's on the video if you want to see it. But 12.2 due tomorrow. You were supposed to turn it at the beginning of class. If you didn't yet, go staple it and then turn it in. Doesn't matter the folder's not there. I can still take it. Bye, guys.